What did you just say?
I said we're going to start recording now. Rational expressions. Now, here's how was the Khan Academy yesterday, by the way? Was it hard?
I went crazy.
Do you remember how to factor? Okay, so y'all have factored before. Aww. Okay, let me ask y'all this. How did she teach y'all to factor? Did she teach you to factor? Okay. Well, how did y'all learn to factor? What did y'all do to factor? How did your tutor teach you? Like, did y'all do grouping? Is that how y'all know to factor? Like, for example. What? If I asked you to factor that, what would you do? Okay, so you get 12x squared.
It's got to be 12 and 1, right?
But they're both negative. Okay, so let me try to refresh you and see if we remember. So when you've got a quadratic, you've got steps, and I promised y'all I would. And then once we do that, we look at our A and our B and our C, list those out, multiply the first and the last together. Right? Do y'all remember doing this?
Look at that picture.
Let's just go.
This is steps to do it. Okay. And so there's no leading coefficient. Y'all can do the ones. You know what, the ones where there's not as much puzzle to it. You don't have to, yeah. Okay, so this way works all the time, whether it takes the coefficient away or not. So you multiply the first and the last together, and if you follow along that sheet with the steps, it's telling you the same things that I'm doing here. But 4 times 3 is 12. That's where the 12 is coming from. And so now the puzzle part of it is what multiplies to this, but adds to this. Negative 12 and negative 1, right? They've got to multiply to a positive number, but they've got to add to a negative number. So you thought it was what? Right, that's the shortcut if there's no leading coefficient. Like if you just had x squared plus 5x plus 6. Yeah, you'd be looking for that 2 and 3, and you could say x plus 2, x plus 3, but that only works shortcut that way because the leading coefficient's a 1. But you could always do it, this way always works, whether you can shortcut it or not. You can always do it the long way. All right, so I'm going to fill in, instead of writing negative 13, I'm going to write negative x and negative 12x. Thank you, Logan. So now I slash. This is where everybody keeps. Are y'all following with me? Those of you who didn't have me last. Oh, y'all had me. All right. Now I GCF it. So I look at the first two and I say, what GCF it? Oh my gosh. What can I take out of the first two? In other words, what can they both give up? They can both give up an x. And what's left when I take that out? The middle sign always stays, but if the middle is a minus, it causes my last sign to change, so you have to be careful. What can you take out of the last two? 3. What's left? 4x minus 1. I need to change that sign for 1 since the middle was minus, but I divide them both by 3, right? Now what should happen if I've done it correctly, the two parentheses should match. When the two parentheses match, you take it out, you write it just one time. Nope, do away with it and then write what's left. And that makes up your second parentheses. That's it. That's fully factored. As long, yes, that's fully factored for quadratic now. Now, I what? Oh my gosh. Calculus was giving me a hard time about that this morning, too. Okay. Your favorite F word? Okay.
All of them
Now,
that have a base.
we moved on. We talked about some special patterns, right? Do y'all remember the special pattern? And I'm reviewing all this factoring stuff. Please, please, please speak up if you need some extra help with it, because this is going to be the key to what we do today is factoring. Another factoring one? Like that. Okay. Let's do... Okay.
Oh, yeah, that's my bad. Never mind, must be adding.
What are the two things you filled in the blank with in the middle?
-1.
-1 and -25. I should have picked one that wasn't the same. I don't know. I'm clearly not. Okay. This is just the backwards of foiling out is what we're doing. This splits up. First outside in. Oh. All right, slash it. What can you take out of the first two? What's left? The middle sign stays. What can you take out? 5. What's left? And why is that minus and not plus now? The sign changes because of the minus in the middle. Now these two parentheses are exactly the same. One time. And really what I'm doing is factoring those out. And it leaves me with absolutely it is. What about, see how much you remember? Huh? Oh no, this is something, this is still factoring, this is special pattern.
This is like
Nope. That's quadratic.
Oh, I know what it is.
That's perfect square triangle. That is one of them though. That is one of them. What about 2x and 3? It's a difference of two squares. So if you ever see two perfect squares with a minus sign in the middle, you can take the square root of each, 1 plus, 1 minus. That's, in general, if you have a squared minus b squared, you can factor that as a minus b, a plus b. Square root of each one with a minus, one with a plus. And then Dozier said something about the dance we did. The triple dance? The square dance. Let's see.
Oh,
So I could go through and I could multiply the first and the last together, but I'd get a huge number, right? Like, that's no bueno. No, 3 doesn't go into 49. It doesn't. 14 times. But it doesn't. So it doesn't. It's stupid. Okay. So I can't take out a GCF. So instead, I'm going to look to see if it's a special pattern. And what do you notice about this right off? The ends are perfect squares. Does everybody see that? That clues me in it might be a special pattern. I need to go through and check to see if it's square dances, though. Square dancing, and remember that second sign has to be a plus in order for this to work. Square dance. If you take the square root of both ends, square, square. Look at you. Square, square, multiply, and double. So it's square, square, multiply, and double. Y'all remember? Okay.
I never do that.
Yeah. Okay, so square, square, multiply, and double. And I do it like that because that's the way I see it in the problem in my head. Is square root of this is 3x, square root of this is 7. So square root, square root. So square, square. Then you multiply them together, you get 21, and if you double it, do you get what's in the middle? Yes. If that happens, then it's an easy factor. Yeah. I'm old. Okay. Thank you, Davis. Thank you. I appreciate that. Okay. So how do you write it? How does it factor? It factors as the square root of the first one, so 3x, the very first sign, and then the square root of the last, and all you have to do is put a squared on it. It always has to be whatever the first sign is. So the factor in the pattern in general looks like this. It could be plus or minus 2ab. So if it looks like this, the ends are squares. If you take the square root of the ends, put them together, and double it, you get what's in the middle. Then it factors as yep. Yep. Yes. Yes. Those were all the quadratic special patterns we learned. I promise I'll find that sheet and I'll print it for y'all so you can have this as a reference. Does that make sense though? Okay. What I didn't give you yesterday, I don't think, that you're going to have to remember for today. No, but, I mean, you have to know that, but I'm trying to, because y'all told me you didn't remember anything, so what I'm trying to do is, instead of, like, giving you a crash course in Algebra 2, if I fill in the holes as we go, like, before I give you the pre-cal stuff, if I give you the background Algebra 2 stuff, then maybe it'll help you. See what I'm saying? Instead of sense. Well, technically, pre-cal is like a deeper dive into Algebra 2 for a lot of stuff. But if you're talking about trig, that's after the second element. But trig is trig. It's not, I mean, it's all, pre-cal is just a class preparing you for calculus. It's pre-calculus. I could get you through calculus. If you had a good foundation out of it too, I think. They say it's a prerequisite here. If I had a strong enough student, I would sign off for them because I could fill them on. No, I'm not saying you would, but they've got it set up here where it goes in this order now. Because then what would you do? Okay, back to this. Let's see. I'll do E. It's not a quadratic anymore. Why is this not a quadratic? It's cubes. It's not different because it's a plus, but it's sum of two cubes. Okay, so I heard x plus 5, and you're on the right track, but you're not quite there yet. So did y'all learn this? Okay. Yeah.
You can.
It's okay. Y'all don't run and drop because you think you're not going to be able to do it, because it's not, because I promise I'll get you through it. Even if you didn't learn it, we'll get through it, I promise. Okay. Huh? All right, so this is the, and I have a reference sheet I will run y'all off too. I keep looking at like y'all and you, because I know y'all have Miss Otto and, but anyway, it doesn't matter. It doesn't matter who you had or what you had. We'll make sure you get through it. All right. So I recognize this is not a quadratic, right? Because it's got a degree of 3 and stuff. Yeah. So, but I noticed that both of them are powers of 3. Yes. X times x times x is x cubed. 5 times 5 times 5, 125. So this is one of those special patterns. This is a sum of 2 cubes. Has to only be 2, but it could be plus or minus. We got sum or difference of cubes, but only a difference of squares, right? When we did this has got to be a minus sign in the middle. Can't be plus. But this one could be plus or minus. This is where we do same change plus. Remember? So we do little parenthesis, big parenthesis.
Oh my God.
Don't you ask me a question about that homework sheet?
No, it's not that important.
You're right. Same change plus.
And look, that's what John did, but.
All right. What times itself 3 times gives you x cubed? What times itself what? What times itself 3 times gives you 125? Now I'm going to use these to write the second parentheses. Are y'all, is it coming back to you now? It's all coming back. It's all coming
What,
back. So you square the first, you square the last, and you put them together in the middle.
You do that up, you like AB and then A squared.
Square the last, so let me show you the general pattern. A cubed plus B cubed factors as A plus B, A squared minus AB plus B squared. And A cubed minus B cubed factors as A minus B, A squared plus AB plus B squared. Yep. It's same change plus, yes. No, it's not. The last one's always plus. Oh my gosh, can we not make random crap up?
What?
I'm gonna need to switch like the back row and the front row.
I can't see about this.
Yeah, I bet.
There's no way they can see behind y'all.
No, I can't see.
Go back to difference of squares. Like all the way back to different right there.
Can you go to sum?
Sum of cubes. Okay. If you can do those things, you can do the homework. But I haven't gotten to the new stuff for the homework, like what you're going to do. But now, remember in Algebra 2, we did polynomial division, right? Where we did long division or synthetic division. Did y'all do that?
Yeah.
We're not going to do that right now. We'll hit that again whenever we get a little bit further. But for right now, I want to talk about rational expressions. So here we go. No adding or subtracting, Logan. We're not going to get there today. Just the multiply and divide part today. Well, the other part will be tomorrow night. Put this in as 2 nights.
You broke it.
I broke that snake that they put up here. I don't know. I'm sorry. Yeah. Rational expression. What is? All right, so this is where we were going to start. I just don't want y'all to think that I'm up here. If y'all need a break in between and you need to go get a sip of water or you need to stand up and stretch or you need to get a snack, they're supposed to be bringing y'all lunch today. Let me know because this is a lot, but I'm also filling in background. So,
Brain break.
do y'all need a brain break?
Yeah. I can just.
Okay, we'll go. Will you just put them in your book bag or something? Because, I mean, I don't need them. All right, so rational. What's a rational number? If I told you we got all these different types of numbers, what do I mean when I say rational? Okay, it can always be expressed how, though? It's another favorite F word. It's just fraction. That's exactly right. Rational fraction.
Fraction is not my favorite.
All right. When you see the word rational, think fraction. Okay, and that's exactly what this is fraction. So we're looking at these fractions. It's gonna look kind of similar to the polynomial long division, but these are gonna be, we're not gonna do that this way. We're gonna try to simplify them as they sit instead of trying to do a division type thing. So here's the key to rational expression simplification. It's factoring. If you can factor, you can. What do you think it said?
No, I don't.
Okay. Before I get into examples on simplifying and everything else, let me show you this. And Logan, this is kind of the question you were asking, but I think you got it answered now. If I have x plus y, and then I have, let's make this x minus y. Don't write in pen in here. And then I have y minus x. What's the relationship between these two? Because they look really, really similar. But they kind of are a type of inverse. They have an x and a y, but could you rearrange them anyway to make them look the same without changing their value? But here's what I want you to know, Snippet. I don't know why students have never heard this before whenever y'all get to here, but if you look, this x is positive, this is negative, yes? This one's negative, this one's positive. So do you agree that every single sign is different? So then what if I wrote this as -1 times, and I changed all the signs inside? Couldn't I rewrite it this way so that those factors look the same? That's going to come up a lot in simplifying rational expressions that you see that. So if you see two things that you need, and you'll know what I'm talking about in just a second, that you need to cancel out for some reason, if you see that every sign in the parentheses is opposite, you can always do this in order to cancel out. Okay? All right, here's a helpful hint. Here's what we're going to do. We're going to take fractions. We're going to start with simplifying. We're going to move into multiplying and division. And this is really easy. This is things that we were supposed to get to them last year and we never did. So this was the next unit we were supposed to get to, which is why we're supplementing in here with rationals, because it's really important. All right, let's simplify first. When we simplify, I feel like I've written this like 3 times, but I'm really ready to do it now. Simplify rationals. Just as a reminder, if I have, let's say I have x, y, z over a, b, x, how do you simplify that? That's exactly right. Because I am multiplying, and this only works when you are multiplying, I can cancel out what's being multiplied top and bottom. Do you agree with that? Okay. Now be very careful, because if this was x plus y times, or let's just say it's just x plus y over x plus a. Could I cancel out y? They're being added, or you'll kill a kitten. Don't kill a kitten. Can't do that. Okay? You cannot ever, ever, ever cross them out. So before you start crossing out, before you cancel, every plus or minus has to be in parentheses. And what I mean is, you would have to put parentheses around this and around this, and then you can only cancel out whole pieces. Okay? We can't cancel out individual pieces out of those. So as we simplify, what we're going to do is we are going to factor everything we can and cancel what we can. When I say factor everything, I mean factor completely. I factor it, I look at the parentheses that I have, and I see if I can factor it any further. And then I look at those parentheses, and I see if I can factor it any further. Who put that picture of me up over there? Okay. Let me show you an example. He wasn't even here. Yes. No. No, but it was back behind my desk this morning. Somebody hung it up. Factor everything and cancel what we can. You want me to wait on you? I'll wait a second. We'd be happy to wait on you now. We haven't done anything yet. Yeah. All right. Simplify. This is a rational expression. It's a fraction. Doesn't matter that there's other stuff up top and in the bottom, but my goal is to simplify this, okay? I cannot start canceling out yet because all of my plus or minuses are not enclosed in parentheses just yet. So what I need to do is go through and factor everything I can. Difference of cubes. I see a difference. Yeah. I see a difference of cubes up top. Everybody see the difference of cubes? All right, so let's factor the difference of cubes. That's little parenthesis, big parenthesis, same change. What goes in the first parenthesis? 4K and 1. How about the second parenthesis? Multiply them together. 4K, and then the last one squared. 1. Same change plus. Can you factor the denominator? Probably. See if you can do it. Do it. I think we did this one together already. Yeah. What did we get when we did it earlier? I hope 4K minus 1 was one of those factors. 4K minus 1 and x minus 3. All right, now I want to look at... You good? Oh, I don't know. We did it earlier whenever we were practicing factoring. It's a slasher. All right. Factor completely. So now look at all of your parentheses that are there. Can anything be factored any further? David said yeah.
No, not that.
Not factored further. We're done.
Cancel out 4K minus 1.
Okay, whenever you do a sum or difference of cubes, that last parenthesis won't ever factor any further for you. So there's a short one. So you're exactly right. Now here's what we do. Now we look for what cancels. And these are fun because we're canceling out whole chunks, right? So I'm going to cancel out this whole 4K minus 1 factor here. And I can do that because every plus or minus is enclosed in parentheses, and these are being multiplied. So I can cancel that whole thing out. What's left when that's gone? That's right. 16K squared plus 4K plus 1. And on the bottom, can I cancel any of those K's out? No, I like kittens. I don't want to kill them. I'm done. That's simplifying. That's as far as you can go. That's simplifying, yeah. We're going to multiply and divide, but it's all, no, it's not. No, it's not. No, it's not. Let's do one more simplify, and then we'll move into multiply and divide. Oh my gosh. You don't want another practice? Do this one by yourself. Whoever gets this one. Davis is giving out hundreds up here. I'm just using, listen, I printed out a page so I could get ones that factored nicely and would cancel out without me coming to sit up here and think about it. All right, Mark.
Oh, I got it. What are we doing? Get them with one. I don't know. That's going to be we do the same change key paragraph.
Oh, you do?
Yep. And then, hold on.
Pardon the interruption. At this time, teachers, please refer to the validation list sent by Ms. Montgomery. At this time, any student coded in blue that has not yet picked up their validation forms needs to report to the lecture hall at this time. Again, that was an email sent in a Google Doc by Ms. Montgomery, and it's anyone coded in blue.
Okay.
You can take 18 out of
We'll try to take a GCF out first. See if we can GCF it.
I'm sorry.
No, you're not.
This has nothing to do with what we just like.
Yes, definitely should. I'm glad you knew the list.
If two things are out of the parentheses with no sign, it may be.
Wait.
What'd you just say? I wasn't listening. Lecture hall. Have fun.
No, stop.
No,
I
David
don't
said
even
stop.
know.
I don't know that. Oh, don't do that, David.
No, here.
My goodness.
I'm sorry.
All right, what'd you do first? Look at the top. Take a GCF. What'd you take out? 12 in. They're both divisible by 12 in, right? So I can take 12 in out of the top, and when I do, what's left? N minus 4. Is anybody confused about that? Y'all okay? All right, look at the bottom. Is there anything I can take out of the bottom? 18n squared. When I take out 18n squared, what's left? 16 minus n squared. Now, I told you to factor completely. Is that factored completely? No. What do you see? Difference of squares. That's exactly right. Where is that at? At the bottom. That's right. It is. It's just backwards, but that's okay. So this is going to be, so up top, I'm still sticking with that same 12n times n minus 4. I've got 18n squared. How does a difference of two squares factor? So 4 minus n, 4 plus n. Well, I can't do it the other way because it's a minus. That would have to be n squared, negative n squared plus 16. But,
No, you have to do the negative 1.
That's right. There you go. Remember I told you that was going to pop up a lot? It doesn't matter. Okay, we can, but first we've got to factor out negative 1. Remember in the very beginning whenever I told you if they look almost exactly the same, but they have opposite signs, how you factor out that negative 1? I've got a positive n and a negative n. I've got a negative 4 and a positive 4. So they're the same other than a sign. So what I'm going to do, and it doesn't matter which one you do it to, I think I'll do it up here. I'm just going to take out a negative. So I'm going to say, really, this is negative 12n. And then that's going to make that 4 minus n over 18n squared over 4 minus n 4 plus. That, to me, is the hardest part because it's the hardest to see for some reason. You know there's something there to do, but you can't quite put your finger on it. But that's what it is. Now I can start canceling. So y'all ready? Well, I took a negative out. So what happens if you distribute a negative 1 to that? I'd get negative 4 plus n. And if I switched up the way that was written, I'd get n minus 4. Right? So that's all it does, is it changes that up. All right, so yes, I'm going to cancel out the 4 minus n. Everybody okay there? All right. Is there anything else to simplify that I can do here? Leading coefficients can definitely, if I had a fraction that was 12 over 18, And if you're not sure, use your calculator. Do 12 divided by 18, math, enter. Right? Do 12 divided by 18. Enter. Math. Hit math. Enter. No. Math. Enter. What do you get? 2/3. So now I've got negative 2n over, and I realize that I'm taking way more steps than what I have to, but I want you to see where everything's coming from as I go. I can also take an n out. Remember those exponent properties if it's in the top and the bottom? So I've got an n up top, 2 n's in the bottom. That leaves me how many n's where? 1 on the bottom. So I get negative 2 over 3n times 4 plus n. And now I'm simplified. Yeah, because they both had, this was 2n over 3n squared is really like this, and so one of them can cancel. All right. No, you're not. Watch this. Because multiply and divide is just like simplifying, and that's why I can throw that in here. How do you multiply fractions? Because remember, rationals are fractions.
Oh, you cancel it.
Wait, what? You just what? Multiply how? Across, straight across, right? It's top times top and bottom times bottom, yes? If I have x over y times a over b, then it's just, I always tell my kids I'm lazy. I just do this. Well, really, that's xa over yb, right? Because that's how I multiply fractions. Top times top, bottom times bottom. I'm going to do the same thing with rationals, and then I'm going to try to cancel them out and simplify it. So let me show you what I'm talking about. Y'all ready? This is when it gets good. I promise I'm trying to get done so you can have time to do your work. So you don't have time.
He's on his phone. Line him up.
Logan.
Oh, Logan Rose. Outside.
My advice to you before you do anything else on the multiplies and the divides is to, again, factor everything. So I'm going to give you just a minute, and I want you to factor everything. This is the problem. You could if you want to, if you see what to factor. What you factor for? Yeah, you got to factor it.
This is like 4 times 1.
It is. That's why rationals are such a pain in the butt. Oh, that's not my favorite A word. Apple. What isn't my favorite A word? Factor.
Hey, Logan, what's your favorite F word?
I'll tell you right now, it's not fraction.
It's fraction. His is fraction. He told me.
It's not fraction either. It's friend.
Oh, how sweet.
Minus the fact that I don't have any of them.
You're right.
Other than that, it's fine.
My favorite A word.
Number one on the homework.
My favorite word is fashion.
That's not right.
Will you stop? What is it? What do you want? Go away. What? What do you have to do with it? What? I don't even know if I did it.
Logan.
Let me see if I did it right. Yeah.
All right, so the first one was just a normal factor. If you want to go through and slash it, remember, if it's a quadratic and that leading coefficient is 1, you don't have to go through all that slashing. You can just say what multiplies the negative 24 and adds the negative 10 and fill those in. That's the easy factor, right? Yeah.
You messed up one.
No, you're right. That multiplies, that doesn't work. You are right. What multiplies to negative 24 but adds to negative 10? It's not 6 and 4. 12 and 2, yeah, sorry. Good catch. I do, see? You're welcome. I'm making you better math students. Okay, now, the bottom one, all I did was factor out an x squared. Then as I moved to the second fraction, all I did was factor out a 5x. And then on the bottom, again, what multiplies to 48 but adds to negative 16, negative 12, and negative 4. So now, because these are fractions, right, and I'm multiplying, it makes it a really easy. I can just multiply straight across. I absolutely would. And in fact, I don't even rewrite it. When I get to this point, I make one big fraction bar, and then I start canceling out. All right, x plus 2, x minus 12, x minus 4. Absolutely, because you're multiplying. Now it's just one big fraction. Well, but it's not even 5x because look, there's 2 x's here and an x here. So it just simplifies. Isn't that satisfying? Look at what we started with and look at what we ended with. Yeah. That's it. All right, I'm not going to waste any more time other than to tell you one more little trick before I shut up. I don't like to teach this long. I really don't because I like to have time to work. But if you divide fractions, what do you do?
Flip.
You flip. It's same, change, flip. You multiply by the reciprocal, okay? So that's exactly right. If this was a divide sign, I would just change it to multiply and flip that fraction over and do everything exactly the same. Still cancels the same way. You change it to a multiply problem. So if I had x plus 2 over x minus 1 divided by x minus 1 over x plus 3, I would change it to, bless you, multiply. And then I could cancel out anything I needed to at that point. No, because you're dividing and not multiplying. And no, they'd be right beside each other, so yeah. X over x squared is 1 over x. All right, so I only want you to go through 6 tonight. You got 6 problems. 1 through 6. 6 through 6. Huh?
I did 7.
Yeah.